Just a quick review. What are the two ways like to optimize multiple data sets operations like joins, lookups, and exists? One is broadcasting. Second one, partitioning. In case of broadcasting, you have three options. Auto. Second one, fixed. That means we can fix either left side or right side. And third one, whether broadcasting should not be done. For that, off. What is the importance of broadcasting? Already we have discussed. If you did not attend that session, please go through. Please watch your previous 4 sessions. What I have done on Saturday, I think, right? Yeah. And in the case of partitioning, you have many options. One is round robin. Okay, this is for set partitioning. Main, if you talk about the options, number 1, use current. Number 2, single partition. Number 3, set partitioning. In the case of set partitioning option, again you have 5. Number 1, round robin. And number 2, hash partitioning. And number 3, dynamic range partitioning. And number 4, I too forget, man. Range part, that is the range is based on the condition range. What is that name? I will check it. Fixed range. Fixed range partition. And number 5, key partition. This way many number of partitions. Already we have done explanation about round robin and also hash partition. Let me check the chart. Yeah. And dynamic range partitioning and fixed range partitioning and key partitioning. In the case of round robin, you can choose number of partitions. Okay. And if you talk about hash, in the case of hash also you can choose number of partitions. In dynamic also. In the case of fixed range also. But here, you cannot choose number of partitions. All of you understood. First, I am coming from reverse direction. First, we will be discussing about the key partitioning. Based on the key column, what you have selected. Within that column, how many unique values are there? For each one unique value, one partition. Understand? For example, department file is there. Maybe employee data or whatever it may be. Think that there is some departments. The departments I have from 01 to up to 99. 99 unique values are there within that. 99 partitions will be produced. That means all department 01 will be into one partition. All records of 02 into one partition. Understand? For example, let's talk about employee file. What are the column within this employee file? in our previous examples, ID, name, salary, gender, department number. But in this data, ID is unique. Department number is duplicate. First employee 11, second employee might also be 11. By mistakenly, if you made ID as key column in the partitioning, one record in one partition, because employee ID 101 available only one time, that particular record into one partition. Again, second employee 102, that is into another partition. That to 101, 102 repeated only one time in that file. So at that moment, you should not go unique column as key column in the partitioning. But I go, suppose if I choose gender as key column for the partitioning, what will happen? All males into one partition, all females into another partition. If I choose number of partitions as 2, okay, if I choose, I'm sorry, here I cannot choose, remember the point. Within the gender column, how many unique values you have? 2 values, males, females, maybe another value, nulls. So in such cases, all male values, that means all the records of males will be into first partition, all records of the females into next partition. If data is not cleaned, there is a chance of nulls. All nulls will be into another partition. Understood? For example, for your file, I have selected department number as key column. Okay, I have 1 lakh employees. I have 1 lakh employees, but all employees related with 99 departments. How many unique values are there in the department number? 99. 99 partitions will be produced. All 11 people will be into one partition. All 12 department people will be into other partition. Understand? This is the behavior of key partitioning. In the case of key partitioning, remember, you cannot choose where is this value. You cannot choose number of partitions. So how many partitions will be allocated means what is your answer? Depends on number of unique values in the key column. Okay. Here the answer, number of partitions equal to number of unique values in the key column. Understood this? So this is what our key partition. Next, fixed range partition, just to verify it, whether you can choose number of partitions or not. All of you observe on the screen. From the optimize, I have selected round robin. What about this number of partitions that I can select? It should be more than 1. It should be more than 1. 2 or 3 or 4, anything that you can choose. That in case of round robin, I can choose. In hash partitioning also, I can choose. Understand? But what is a hash key column? For which column the hash should be applied? You have to select the column. And what about dynamic range? Here also you can choose number of partitions. And fixed range, you can choose number of partitions. Got it? And key value. If I choose key, I cannot choose number of partitions. Got it? So only here I have to select the column, single column or multiple columns that you can select. Got it? For example, I have selected two columns. One column is ID. For example, for my employee file, one small point. If I select key columns, two key columns. Number one is department number two is gender. Two columns I have selected. Within the department, what are the possible values that I have? 0, 1 to 99. Here, what are the possible values for me? Think the data is already cleaned. I have male and female. Now, how many partitions? 0, 1 male. All males of 0, 1 department will be into partition 1. All females of 0, 1 into partition 2. 99 into 99, 99 into 2. How many partitions? 198 partitions. On that way, the key columns that you can choose as single or multiple also. Got it? So generally when we go for this is under one category, there is huge volume of data, then you have to go like this. Suppose only males of 0, 1 department, some 10,000 rows. Females of 0, 1 department, some 9,000 rows. Maybe little up and down. Under one category, there are huge quantity of records are there. In such cases, instead of searching for all the data, whenever your process needs males of 0, 1, directly it will contact that particular partition and fetch all the rows during the process. Understood this one? So this is one of the options. Suppose if there is no 0, 1 males as separate partition, for example, tomorrow your query is trying to fetch the information of select star from your table where department number is equal to 0, 1 and gender is equal to male. If it is my query has to scan all the data. Whenever the data is partitioned, during the runtime, automatically it will contact that particular partition and it will fetch that information. Lot time is saved or not, like that. Okay, when to use what partitioning? In the next class, you will be getting the clarity. Just observe how each partitioning is working. All of you clear about round robin and hash and key partitioning? Okay, already in last class, we have discussed about round robin and hash. And today, the first part, key partitioning. Got it? And come to the fixed range partitioning, the fourth one. Fixed range partitioning. Observe this. It is asking you not the column, it is asking you condition. Based on the condition, you can partition the data. For example, I am giving you a condition from our sales file, price greater than 50,000. Now data is split into two parts, into two partitions. Of course, the partition number also that you can choose. I have selected two partitions. Number of partitions I have selected 2. I have selected 2. Then it is asking you condition. The condition is price greater than 50,000. What are the possible rows? Greater than 50,000, one partition. Less than or equals to 50,000, another partition. That means all true records. That means matching records with the condition into partition 1, remaining into partition 2. Got it? Based on the condition, you can split the partitions. Suppose fixed range. Check it here. It is asking you condition expression. Look at the last box. The above number of partitions. Suppose if I have given the column, that expression, let's say the expression price. Based on the price, I am giving some condition. price greater than some 50,000. This is my condition. Now runtime data is divided into two partitions before starts execution. Above 50, partition 1. Condition false statements into another partition. Got it. And plus, this is for second level condition. For example, if I have number of partitions as 3, now data to be split into 3 partitions. If number of partitions are 3, you have to give 2 conditions. This is for true. If this condition false, it will check second condition. Still false, into the third partition. Okay. For example, observe this. I selected number of partitions. 3. Here I have condition 1. Price less than 75. Condition 2. Price less than 30,000. I am not giving third condition. Now what will happen? How many partitions? 3. Which are less than 75. All the things will be into first partition. Just give the condition like this. First give the 30. Better way is give the 30. And second way is 75. Now you don't mismatch. All less than 30 into first partition. If this condition falls, then only it is coming to the condition 2. If first condition falls, then only it is coming to the second condition. First condition false means what, sir? Definitely value is greater than or equal to 30, right? Then 30 to 75 will be into second partition. Still false. Suppose where price value is 80,000. 80,000 first condition false, second condition false. That will be into third partition. On that way, conditionally you can split the data into your chosen number of partitions. Okay. So in the case of fixed range partitioning also, you can choose number of partitions. But here in the above key partitioning, you cannot choose that number of partitions. Based on how many unique values are there in our key column, that many number of partitions will be created. But that is very dangerous. Take example of Amazon products. Product ID is the partitioning column. Suppose so for the sales transactions file, every sales transaction file related with some product ID. If product ID is a key column, what are the number of unique products in Amazon? Billions of products are there. So that billions of partitions will be created. Again, if these partitions have to be broadcasted means you cannot do. Understood? So that's why like more and more unique values are there. Don't go for that one. I can go for the gender. I can go for department. Generally take any organization, maximum 1,000 departments or 2,000 departments. Even government kind of organizations, if you consider, max to max 10,000 departments in entire India. Not more than that. At the time I can go, but if the number of departments are even lakhs or crores, at the time you should not go. Understood? So on that way, like, okay, later in the special discussion, we'll see when to use what. In one single day, you cannot understand all the things. Okay, so this is about fixed range partition. Our explanation part done about this, and final pending is dynamic range partitioning. First of all, why dynamic range partitioning is required? A small clarity. In the case of fixed range, suppose my condition is this one. Gender equals to male. What has to be done? According to your expectation, and number of partitions are 2. I want to divide them into 2 partitions. What is expected functionality? All males into 1 partition, all females into other partition. Got it. So observe here, example, there are 100 records. Okay. Example, there are 100 records. 98 males, 2 females. What will happen? All 98 males into partition 1. Remaining only 2 females into partition 2. Okay. Not 100 records, 1 lakh records. Not 98 males, 98,998 males. Okay, still there are 2 partitions. But in the first partition, not 98, 99. That many number of males are there in the first partition. Suddenly, when come to the second partition, only 1 or 2 females. This kind of problems are called data skew. Skew, S-K-E-W. Or else there can be only 2 males and remaining females. In this case, left skew happened. In the first case, right skew happened. Got the point, sir? Definitely one partition will create more burden on the system. Small partition can be fitted into the memory, but big partition cannot be fitted into the memory. Got it? That's why the dynamic ranges partitioning will be there. Of course, for the gender, you cannot use dynamic range partition. Because gender means you have only 2 things. Other than gender, some other column that you have to select, where values are continuously flowing, where value ranges are continuously flowing. Got it? So in the case of dynamic range partitioning, what will happen is, observe. I repeat that. There are values. Suppose salary is a column. I selected salary as the column. The first person's salary 10,000. Next person's salary 20,000. Next person's salary 30 or 3. And next 5, 2, and 50. Sorry, 5 only. Again 10 I am taking. 20 I am taking. Here 30. Like this. Understood? Sir, in this data, what is the minimum value? 2,000. Maximum value 30,000. The basic behavior of dynamic range partitioning is, first it will take a mid value. First it will take a mid value. Okay. How to take the mid value? The minimum is 2,000. Maximum is 30,000. Divided by number of 2. Average of these 2. Average of minimum and maximum. 30 plus 2, 32. That means how much? 16. Below less than or equal to 16, it will keep into one partition. Above 16, it will keep into other partition. But still data skew chance is there. But when compared with the previous process, less probability. Okay, think that this is the daily job running. Today, less than or equal to 16,000 occupancy more. Tomorrow, tomorrow new data greater than 16,000 occupancy more. Got it? This is called dynamic range. Got it? For example, the key is the column is ID. My ID is starting is like this: A1, B1, or C2, or A2, like this. In this case, Suppose I have chosen 26 partition, 26 partitions only. So in this case, basically all A's into one partition, all B's into another partition like. Okay, but no guarantee. Based on max value and minimum value. Suppose there are B records are only two, that may coming into A and B can be into one partition. C, D, E can be into one partition. Understand? On that way, dynamically it has some intelligence. So actually this concept is inspired from the Spark dynamic partition. Okay. Spark version 2 onwards, Spark dynamic partitions a topic. That means that new technique introduced into that one. From that it has taken. Got it. Sometimes, but for tomorrow, for today data, that is 16,000. For tomorrow data, the mid value can be even. As for new data, maybe that can be average, can be changed or not. Maybe 20,000. At the time, less than or equal to 20,000 into one partition, greater than into another partition. Suppose if I have selected 3 partitions, again that has to be split into 3. Got it? So based on number of partitions that you have selected, values will be approximately equally distributed. Approximately equally distributed. So not exactly based on the mid value or something. Something it is always trying to balance both partitions. Especially in the case of a character IDs, I told you maybe A and B might be into one partition, only C can be into other partition. Based on the data ranges, it tries to equally distribute among all the partitions to avoid the data skew problems. If data skew happens, what happens? One particular partition will have more volume of data, large volume of data. Another partition, very less volume of data. Same thing for the gender. If I apply this one, what happens? For the gender, if I apply the dynamic range partitioning, what will happen? It tries to manage. That means in the first partition, only males can be there. In the second partition, males and female combination can be there. Understand? But for all M's to be in one partition, right? For that M, you have to give additional partitioning column. Male and department number to avoid that. Male and department number. That means gender and department number. On that multi columns that you can choose. Understood? So please come back to here. What you call your partitioning types. First of all, round robin. Number of partitions that you can choose. What is the behavior style? First record into first partition, second record into second partition, again third record into first partition, fourth into second partition. On that way, equal distribution, uniformity of the distribution. This is called uniformity of the distribution. And second hash column, some department number of partitions too. Now, the possible outcomes of hash function is always 2. Hash value 1, hash value 2, whatever the data may be. No chance of third value because I have selected number of partitions 2. Suppose for the first record hash value, department number is hash column, hash column. Hash should be applied on department number. First employee 11. For the 11, hash function is executed. Suppose if hash value is hash 0, hash 1. If it is hash 0, the value will be going to first partition. If it is 1, the value is going to second partition. Again, second record. Second record it will take. Suppose if its hash value is number 1, it is going to second partition. If hash value is 0, it is going to the first partition. Understand? So when this kind of model is advantage to you, tomorrow at the time of joining, when our 11 department of employee to be joined with 11 department of department. Okay, instead of searching for the department 11 in all the partitions, directly it will contact a particular partition. On that way, ADF optimizer automatically applies hash function while fetching the data. while joining. Understood? And next, dynamic range, just recently we discussed. To avoid the data skews, that to set them in a sequence order. Range means what? Range has to follow some sequence. Got it? Dynamic, it tries to equally distributes the data among all partitions. And fixed range, conditionally you can split all transactions which are above 50,000 into one partition, remaining into other partition, like that. And key partitioning, meaning of key, how many? You cannot choose number of partitions. How many, based on how many unique values that you have. Based on that, the data is distributed. But very dangerous if you have more unique values. Especially customer ID, if you make a key column. Customer ID, if you make key column, what will happen? For me, not a problem because I have less number of customers. But for a biggest organization, maybe suppose Facebook users are trillions, right? Trillions of users. So trillions of unique values are there. That many number of partitions will be created. Loading that many number of partitions in runtime is very tough. Got it. So in another discussion, we will be discussing about when to use, what is the right scenario at that scenario. So what is the, at that situation, what type of partitioning is best help, we will be discussing. And this is one way, by setting the options, by controlling number of partitions and by choosing a proper partition type, you can improve the performance. And before that other way, broadcasting. Broadcasting to auto broadcasting. What is the behavior of auto broadcasting? Automatically, ADF optimizer will choose whether left side file or right side file to be broadcasted. Generally, it applies a small technique. Which file is small, that it will broadcast. Suppose employee file and department file is there. Employee file is larger, department file is less volume. So in that moment, it will broadcast department. Understand? But sometimes both files are equal in size. At that moment, randomly it will select anyone. Definitely memory loading error will come. Suppose both files are 1 terabyte volume, but here auto is selected. ADF tries to fit 1 terabyte into the memory, but during execution, memory loading error you will get. At that time, I want to switch off. I want to switch off that broadcast. Understand? Then you have to go for off option. But sometimes you want to select not the decisions, the broadcasting file decisions should not be done by ADF. You want to select your own. Then go for fixed. In the case of fixed, left you can select or right you can select or both you can select. Understand? For example, my left side file is bigger, right side file is smaller. I am asking right side file to be broadcasted. If left file has 100 partitions, 100 partitions are distributed into 100 systems. The small volume file is distributed across all the systems. But not only those 100 partitions. In your cluster, how many nodes currently running? In all the nodes, the broadcasted file data is available. Understood? Suppose in this moment, 100 nodes allocated for you. In all the 100 nodes, this broadcasted file is available. All the data is available. Understood? But Spark is, ADF is dynamically allocating the cluster during runtime, so that you don't get any problem over here. Got it? But you have a physical cluster. Physical cluster has 4,000 nodes. but your employee data is available in only 100 nodes. But if you broadcast department file, actual required number of nodes are only 100, but Spark will distribute this department file. Sorry, it will broadcast this department file in all the 4,000 nodes. But actual requirement is only 100 nodes. That is what the meaning of broadcasting. Broadcasting has advantage. Disadvantage is this one. But in ADF, you don't get this problem. Why? In this movement, how many nodes are required for you? That many nodes will be engaged for your cluster. Understood? No need to worry about 4,000 fixed nodes. You don't have any fixed number of nodes for you. Based on the data volume, automatically the cluster is, during that job process only, the cluster is being allocated. This is additional advantage. What Spark, basic Spark cannot do, what your ADF data flows can do. All of you understood my last statement? Clear? Okay, sir. Let's see tomorrow with a new topic. But when to choose what type of partition in one more session? Because continuous theory for the last 3, this is the 4th session, continuous theoretical 4th session. Again, it may damage our brain. The more theory is dangerous. Data skew will happen in our brain. Okay, that's why to avoid that skew, tomorrow we go for some technical part. Again, after 2 or 3 classes, again, I will come back to this one. Right? Thank you all. Tomorrow we'll meet by 7:30. So today's session by afternoon, I will upload it to the drive. Saturday, all 4 sessions already I have uploaded, sir. Please prepare notes. Thank you very much.
Thank you, sir.
Thank you.